Part B is in what direction from P does T increase most rapidly? Decreasing most rapidly will mean maximum decrease. So when you say the maximum increase, that means we having plus gradient. So when you say is the direction of the maximum increase or the direction in which is increasing most rapidly, that will be, we are going to have here the direction of the gradient. So this is the direction in which function is increasing most rapidly at the point 1, 3, minus 2 is the direction of the gradient at the point, is the gradient of the function at point 1, 3 and minus 2, and that's the gradient of the function we have seen minus 20 over 196, and here we get here the result as I plus 3j minus 2. Okay, so that's the direction in which it is increasing most rapidly, and as I will discuss with you, if we are having the direction which is decreasing most rapidly, so we may have minus gradient. You want to find the value of the maximum increase, that's the magnitude of the gradient. So that we want to find, that's what C, what is the maximum rate of increase, that's C, that's the magnitude of the gradient. We find here magnitude of the gradient, here is the value of the maximum rate of increase, maximum rate of increase is our magnitude of the gradient at the point 1, 3 and minus 2 is equal to 20 over 196 into 1 plus 9 plus 4, and we can have this equal to 20 over 14, that is 10 over 7. That's here we decrease this one, 14 is cancelled in 196, and this is our final result. We're going to discuss another example. To find the directional derivative of the function at the point in direction from point to the origin. Here the direction is not given, but information is given. The direction is from the point P to the origin. Point P is given to us. The second part of the question is find the rate of change in this direction. So rate of change is same as the directional derivative. Then is find the direction that produce maximum rate of change of P, f at P. So that's the direction of the gradient. So find we have find the gradient and find the direction of the gradient. So that means that's the direction of the gradient is the maximum direction that produces maximum rate of change. And we want to find the maximum rate of change at P. That means we want to find the magnitude of the gradient. So first we find the directional derivative, and then obviously we find the gradient, and then the unit vector, then the unit vector, and then the direction derivative. So first of all we find the gradient. The solution of this one is we have the function here f(x, y, z), and that's equal to x square plus 4 y square plus 9 z square. I find the gradient of the function at point x, y, z. Our gradient function is f of x I plus f of y j plus f of z k. So we just take the derivative. We get f of x is 2x, y and z are constant, 2xi, then it's 8yj, x and z are constant, then x and y are constant, 18zk. So we want to find the direction at the point 2, minus 1 and 3. So my directional gradient at the point 2, minus 1 and 3, x equal to, get here 4i, y equal to 1, minus 1, 8, minus 8j, and here is the z equal to 3, multiply here z, we have 54. Okay, so this is my gradient. I get my gradient. Now here this is number 1. Number 2, to find the directional derivative, I need here the vector. Now vector is from P to origin. My point P is 2, minus 1 and 3, and my origin is 0, 0 and 0. So P to origin is mean P, 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 O. So from P to O, so here is P to O. This is my x2, x1, x2, y2, z2, x2 minus x1. That give me the vector as 0, minus 2, then 0, minus 1. Then we can get 0, minus 3. So the vector I got here, PO, that is, this is equal to minus 2, 1, and minus 3. I got this vector PO, and here now I can find my part A. I want the part A is that I want to find the directional derivative of the function at the point direction. I have that, yeah, here I find u. To find u, I find the magnitude of this vector. And the vector is 4 plus 1 plus 9, and that's equal to 14 under the root. And I can write my u in this case. My u is equal to minus 2 over 14 under the root, 1 over 14 under the root, minus 3 over 14 the root. Now I have this, I can just write my part A, the directional derivative of the function at the point 2, minus 1, 3 in direction of the unit vector u is gradient of the function at the point 2, minus 1, and 3 at the point in dot product with u. So this I take the gradient and the dot product. So my gradient is 4, minus 8, and 54. Dot product is with minus 2, 1, and minus 3, or 1 over 14 we take common. So when we take here the dot product, I have 1 over 14 under the root, and here I get here minus 8, and minus multiplied here by 3 is 1 minus 62, or we get here minus 178 over 14 under the root. This is my directional derivative of the function at the point 2, 0. This is my part A. My part B is that I want to find here, find the rate of change of the directional derivative. So my rate of change is same as the directional derivative. So my rate of change of the function f at point P in direction of u, I have defined all the things, is equal to du f of 2, minus 1, and 3 is equal to minus 178 over 14 under the root, same as the directional derivative is the rate of change. Then C is part, find the direction that produce the maximum rate of change at P. So the direction which produce maximum rate, the direction which produces maximum rate of change, or as we have done is changing more rapidly, same thing, is direction of the gradient, is direction of the gradient of the function at the point. So what's my direction? I can say here my direction of the function. So my direction is the gradient of the function at the point, this point is 2, minus 1, and 3, 2, minus 1, and 3, and that's equal to, we're having here 4, minus 8, and 54. This is the direction that produces maximum rate of change. Then part D is the, we want to find here, what is the maximum rate of change at P. So maximum rate of change at P is the magnitude of our gradient. So magnitude of the gradient we can write here, this is equal to the magnitude of the gradient at the point here, this is my magnitude of the gradient at the point 2, minus 1, and 3 is equal to the under root sign of 4 square plus minus 8 whole square plus 54 whole square. When square in, simplify this one, we get here the result as 2996. So that's the example, this complete one. So in this example, we find the directional derivative, we find the rate of change, we found the maximum direction of the maximum rate of change and the maximum rate of change. I give you another example.